And they might ask different questions. They might ask the same questions. Either way. But I hope you looked at the review. If you didn't see, I did post a second review this morning. I just thought maybe it'd be nice for me to go and through the test and find similar types of questions and ask so you know the types of questions that will be on there. Both reviews are good. Both reviews are similar. Today we'll just work through whatever problems y'all want to. So, anybody got one to start? Go. 1 and 2. That's the farthest away thing that we've done. So, here we go. All right. Find a polynomial with real coefficients to this degree with all of this stuff, right? First thing you got to know is what is a polynomial? I don't know. Usually a polynomial is like, hang on. Usually a polynomial is written like p of x, right? Sometimes lowercase, sometimes uppercase. And it's always that thing, that ugly thing that starts with like a1 x. Well, actually not even 1. Usually it's n, right? A n x n plus all that crap. Dot, dot, dot. You know, you've seen this before? Yeah. A1 x to the 1 plus a naught. You've seen that before, even though it's ugly. Your brain can think of it, if you're thinking about a polynomial, as it's just the normal thing. Sometimes it's like 2x to the 4th plus 4x cubed minus 2x plus 8. You know, just random. Just think of it as like random stuff. That's just me making one up. Okay, so that's what we're looking for. Find one. With coefficients, we should know those Actually, let me change that color. We know what coefficients are, right? Know those things. To the specific degree, so 4, that satisfies these conditions. So it's zeros of, and what are those conditions? Zeros of 4 with the multiplicity of 2 and 3i. Okay. So the question is, what's a 0? What's a 0? Right? Or a root, or sometimes they call it a solution. Okay. So we've got an x-intercept of 4. Or 4 comma 0, if you like it in more specific terms. Okay. So what I'm going to do is I'm going to take all this information I've got and try to mash it together. Well, I don't know. I only know one format. I only know one format of polynomial where I can plug an x-intercept in. You know what it looks like? It's got a bunch of parentheses, right? Multiplied by each other. When you got a bunch of things multiplied by each other, it's called a factor. So that's called factored form. So we got a bunch of parentheses multiplied by each other. And I'm just going to fill them in. Well, I've got a root, right? What root do I have? 4? So that's x minus or plus? That's the question to ask ourselves. Because if I plug in that 4, it'll cancel it out, right? Turn it into a 0. That's why the name is 0. Ooh, and they give us our multiplicity. Remember what that means? Little tiny number up there. And we know 2 is even, so this is just a side note, even though it actually isn't going to play into this problem. Even means, what does it do? Add that x-intercept. Even bounces, dot, 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 odd crosses, right? That's not coming into this problem, but it's just a note. Even multiplicity, add the x-intercept of 4, it's going to bounce off the x-axis. All right, well, what other 0 do we have?
X plus 3i and x minus 3i.
We've certainly got x minus 3i, right?
But then the law of the, it's the, I'm trying to remember the name of it. It's that law that has the z with the line on the top. It's
complex conjugate?
What's it called?
The law of the complex conjugate, maybe?
Complex conjugate there. form or
Theorem?
Yeah.
Yeah.
It's because of that we know that there's also x plus
Because of the complex conjugate theorem,
we know that
x plus 3i better be in there. Okay? And there's a reason why x plus 3i better be in there. And we're about to find out. Watch this. Watch this. So what are we going to do with all those three things that we just made up? Multiply them all, right? As ugly as it is, we're going to have to do it. So I'm going to do the first two first. Actually, heck, I think I'm going to do that squared thing first, yeah? You do. You have to. Because of the last thing that we haven't plugged in yet. It says the coefficient of x squared is negative 25. Well, I don't see an x squared anywhere, right? I got to multiply it out to get my x squared so I know where to put that coefficient. So here we go. X minus 4 squared. Off to the side, we'll go real slow today. We got 2 hours, technically 5 hours. If you want to stay, you don't have to. So I'm going to go real slow and do every little step. I know I skip steps a lot of times during class, but today's the day to show you every little step. And then I'll post these notes and this video all online. So if you want to go back, feel free. X squared minus 4x minus 4x plus 16. Here's what we'll do today. If you want an extra donut or kolache, and I write a mistake, and you call it when I write it. So sometimes I'll multiply two negatives and it becomes a positive, right? Call the mistake when I write it, and you can come grab an extra thing at a maximum of one extra thing for the sake of my money. So that yields us x squared. Ooh, I need to make that bigger. X squared. Now I'm nervous. Minus 8x plus 16, right? And that's just that first blue thing. X squared minus 8x plus 16. Times x minus 3i. This is going to be ugly. X plus 3i. Okay? What do you want to do next? Actually, I'm not giving you an option. Let's do the other easy thing next.
That's what I was about.
You're gonna because what really cool thing happens when you multiply conjugates?
Well,
they don't cancel, but something in them cancels. The ugly thing always goes away, which is why when you have a fraction with the I, it goes away. Anytime you have conjugates, it's gonna go away. So let's take care of this multiplication on the side. X minus 3i. If you like FOIL better than the box method, feel free. I just do the box method often because I think it's the easiest to visualize. Minus 3ix. Oh, plus 3ix. That's awesome. I can see those diagonals going to cancel. And then negative. I should put this negative closer so you can see it. Negative 3i. Positive 3i turns into negative 9i squared, right? So we got x squared. The two corners cancel. Or they don't cancel. They add together to turn into 0. Minus 9 times, anybody remember I squared's identity? Negative 1. X squared plus 9. Okay. So now we've got, I know it's getting long and convoluted. X squared minus 8x plus 16 times x squared plus 9. So far, so good? Oh, the identity of I squared is negative 1. Because technically I is the square root of negative 1. So I squared is the square root of negative 1 times the square root of negative 1. The square root times itself just cancels out the square root and turns into the thing itself. Just like the square root of 4 times the square root of 4 would be 2 times 2. It's 4. The square root multiplied by itself just cancels out the square root. So, or just memorize. I squared, -1 every time. All right, now we got to do what I usually do it in the way I just call it double distribution. I just distribute stuff twice. So I'm just gonna. Oh really? Oh well, yeah. I didn't think you'd be able to do it all on that paper. The reviews are I would have extra paper for writing it out. The review is much longer than the test. X squared times x squared is. X squared times 9 is. Good job. -8x times x squared is. -8x times 9 is -72x. I beat you. I'm just kidding. 16 times x squared is. And 16 times 9 is. Ends with a 4. 9 times. Yeah, just do it. Calculator.
16 times 9 is
144?
$144.
All right. Any like terms we can combine?
The like terms that we can combine is to the power of 2 because it is the same thing.
Okay, so that one stays the same. That one stays the same. 2 and 2 combine to get you 25. And -72.
It doesn't combine with anything because there is no other.
What do those things get you? The -72 and the 144.
I thought the negative.
Oh, that's -72x. Good call. So -72x plus 144.
Yeah.
Okay, we are almost done now. What did the question ask us to do? And it said the coefficient of x squared is -25. What is the coefficient of x squared? So what do we need to do to this whole dang thing? We are going to take this, to make this true, we're going to multiply the whole dang thing by, what would make that coefficient -1, right? And now if I distribute that -1, P of x actually equals -x to the 4th, positive 8x cubed, -25x squared, positive 72x, -144. And that is a good answer for your polynomial. Ugly as it is. I don't know. It's good to know. I mean, we didn't do anything that we haven't done. We just did it all in one big problem. If this was on the test, it would be on the free response section, and it would be one of the 3 problems, or one of the 2 problems. So then I really should, to be safe and fair, I should backtrack, just to be safe the whole time through, that -1. Not that the answer changes, but just because P of x doesn't actually equal all this stuff that I said, right? This isn't P of x. This is P of x minus that, or without that -1 being applied to it. So my brain should be thinking, oh, the whole time I was wrong. P of x is technically all that crap times, make up a letter.
Wait, are you sure that that's
No?
the case? Because it says that you want the x squared. Oh, you want it to be negative.
That's why we multiply by -1. So make up a letter. Any letter, I don't care. J. I'm going to put a J in front of here. You could make it X, but X. No, you can't make it X. We already have an X. You can make it A. They do capital A in the book. I'm just backtracking a J, saying I know in my brain I should have been multiplying by some number J the whole dang time to make this what I want it to be. In the book, they call it a capital A. It doesn't matter. It's just a variable that you can keep track of to know. I don't know the thing yet, but I know most of it. If you were going to write this in completely factored form, because maybe it asked you to, our factored form earlier was x minus 4 squared, x minus... What's up?
How are you getting 144?
-144?
Or
Oh, that was me trusting her. That's not my... That's
16 times 9.
She did it in a calculator.
16 times 9. That's how I got it. 16 times 9 is 144.
Wait a minute.
That's not on me.
That's 144.
No, because what I did was I accidentally added instead of multiplied.
I've done it. If you were I, Caden, then I'd be owing you. No, never mind. So if I were to write this in factored form, I need to include that -1 now, right? If I were to write this in factored form, I would need to include that -1 out front. Yeah, absolutely. But you had to get it expanded because of the condition they gave you. Now, a super nicer problem is if they ask you for the leading term changing. If they would have said, hey, the x to the fourth better be a -4, we could have just looked at our factored form and known, oh, look, x. Or, you see what I'm saying? That we could have said x. I know it's got to be multiplied by -4 out here. Like, if they would have asked for the leading term, life would have been way better. Because you could just look at this being x squared, x to the fourth, multiplied by 2 to get 2. Multiplied by -1/2 to get whatever they ask you for. But, yeah, what's up? Because in the problem statement, they said the coefficient, right here and highlighted, of x squared better be -25. And when we did all our factoring stuff, our coefficient was +25. And so we said, oh, that's not the polynomial. I need to change that +25 to a -25. What's the only legal way to do that? Across the board. You can't just change the middle thing. That would have changed the whole thing.
So basically, in the problem, we're looking for that number at the infinity factor.
Which is why I was saying it'd be way nicer if they gave you this x to the fourth. If they said the coefficient of x to the fourth was -1, we'd know it from the beginning because you can look at that and say, oh, that x to the fourth is never changing. But all the middle crap changes all the time.
Don't look at the middle coefficient all the time?
Not middle. It said the coefficient of x to the squared. So that's why we were being careful as to what the total thing should be. Okay. And you said number 2 as well, which I think is similar but quite easier.
Okay, so the degree is 4 and it's the integer that has less zeros.
I'm confused about question 2.
Yeah, I remember us doing stuff like that.
Does there exist? Well, this is just a thinking question, not a answering question. You don't have to do any work hardly. Does there exist a polynomial of degree 4? Okay, with coefficients that have zeros of this, and this. Okay, so let me write it. P of x equals what? What are my zeros? X. Oh, careful. Minus I. If I did plus I, and then I plugged I in, that would turn into an I plus I equals 2I. That's not a 0. That's a 2I. I need it to be probably minus I. That way, if I plug I in, guess what I get? I minus I equals 0. That's a 0 because of the word 0. That's why it's called a 0, is because it turns into 0 when you plug it in. Times, what else do I need to times it by?
Doesn't there also have to be a negative I also because of the
Well, hang on.
theorem?
I'm just working off the problem first, and then we'll talk about the theorem. 2i, x minus 3i, and x minus 4i, right? So it says, does this exist?
Well, the numbers are not real.
Does this polynomial exist?
No, it does.
What?
Yeah, but it's
It needs the coefficients, right? So either one of two things is happening here. Either, what's that thing called? The complex
Yeah, the complement.
conjugate theorem? Complex conjugate theorem not happening here, right? Either the complex conjugate theorem is not happening there, correct?
Yeah.
Or what happens if we apply it to it? What happens if we say, actually, P of x should equal what? X minus I? X plus I. X minus 2I? X plus 2I. X minus 3I? Sorry, this is so long.
That would not be a degree 4.
That would be a degree of?
like
You can count it.
8.
It would be a degree of 8, right?
Yeah.
Or,
Wait, but they never included 4. It didn't include 8I.
Yeah.
oh,
Yep, that's a mistake.
So the answer
come
is
on with it.
no, because the
4i. Degree of 8. Caden, go ahead.
what?
Get a second thing. That was not a good mistake.
I'm not even a second.
Go ahead.
Oh, which one's the not jalapeno?
Non-jalapenos here.
Okay,
Oh, digging deep, dude. That's the most expensive thing on the table.
the non.
No.
This
So
not-
either
not-
the complex conjugate didn't happen, right? So this can't be true. Or if we made it true, it's a degree of 8. So now we're not fulfilling our problem statement. So the question is, does this exist?
No.
No, is the answer.
So
And that-
complex conjugate rule.
If you ever have an I as a 0, as a rocks, if you ever have a rocks of any I form, doesn't matter what it is, 2 plus I, square root of 3I, any I. Rocks of I means it better have the opposite. So rocks of I means it better have the thing called the complex conjugate, which for this is x plus I. For this is x plus 2I. It's literally just the opposite sign, the same root.
Okay.
It says if, so here's a better way to say it, if I wanted to say it. If x, if 2I is a root, then negative 2I is also 1. That's a better way to say it. So then I guess you could say if x is a complex number, then negative x. If x is a complex number and a root, then negative x is also a root. And that's just flipping the sign of the root, not of the factor. We're not flipping both signs. We're not taking the factor and flipping the sign for x and the sign for. We're only flipping the sign for the root itself. Okay?
So
Ugly, weird. We don't see this as much, but it's just a good thought process to think through.
So the thing that
Mhm.
I would say do you think this is also the reason why I said the reason why is because you have to apply the complex conjugate theorem.
Boom,
but that
that's
would
plenty.
lead to which would lead to a
Yep.
a degree of 8.
That's a perfect reason. That's even too much. If you just said, no, this, if you could just, I could look at this and just say, no, complex conjugate theorem says that can't exist. Or no, complex conjugate theorem says it also has to have negative I. Right? Okay. Any more? If you didn't, or if you're a person, I know a lot of people print it out, but if you're a person with a computer and you look, I did post a second review today.
Yes, sir.
It's just similar questions. This was just me looking through the test itself and saying, these are kind of similar types of questions to the test. So feel free to look through both of those. You can look on your phones if you want to as we go through today. Number 3 on,
We do 5.
yeah, I'll do 3 and 5. And then if you want to look through other stuff, feel free. Find all real and complex zeros for this thing. Oh, perfect. This is a good one. These are all the older stuff, right? We've been doing such that log and exponent stuff, which we do need to review. Okay. I think there's 2 ways we could do this. Does that x minus 1? Oh, no. I think there's only one way. You can't do a cool factor thing, huh? Yeah, trailing and leading, but I don't think you can do it pulling out a 4 because then you'd be left with x minus 2 or x minus 3. Yeah. All right. We got to do it the old-fashioned way, which is the new way. Trailing coefficient
Oh.
over leading coefficient. What's the trailing?
-6,
What's the leading?
1,
That leads us to plus or minus 1, plus or minus 2,
plus or minus 6.
3, and 6. And does that 1 on the bottom really do anything?
No.
It never does, right? The other numbers do. They turn them into fractions. The 1 never turns it into a fraction. So we're good with that. If you want to write the 1, you can, just so you don't forget. But okay, so maximum, I only have to try 8 things. So even if you can't remember the quadratic formula, you can't remember how to factor, you can't remember grouping or anything, you could just long divide 8 times and pretty much be set. And that's okay. You're allowed to do that. So here we go. Always try 1 first, right? 1, backwards L. Check and see. I have 3, 2, 1, 0. We're good to go, right? That was me checking to see if we're missing anything up there. We're not missing any exponents. So 1, -1, -4, -6. Drop the 1, 1, 0. This is where I'm going to make a mistake. Hang on, I got to go slower. 0 times 1 is 0.
Because of the space, I'm gonna have to.
Yeah, I would do it on a different paper if I were you. That's what I would always do for these. Negative. Thank you. That's not a mistake. Negative 10. Draw an X. We don't want it. I'm gonna keep it small though for people looking at this later or watching the video so they can see what we tried. Actually, I could draw a bigger X, huh?
Wait, does the video capture audio?
Yes.
Okay.
Yeah. I'm. Yeah. So everybody's gonna hear me talking about all the donuts and stuff. Yeah, come to class. Come to class, you. They can't see that though. What are you? -1? It's not -1. Oh, it's okay. Try 3. Thank you. If everybody could work together on the, maybe we'll do a group test for test 3 for the second half. That'd be kind of fun.
Yeah.
Second half of group test. I'll talk about the second half of this test in a bit because it's a little different than last time. No, I'm hoping it's easier. It's more like I can't talk and do this. I'm gonna make a mistake. I'm gonna owe somebody some food. No. I was erasing it. I already had it like this. 0 chance. No, I'm not counting that one. The other one, I already moved on to the next thing. I was literally like this. So check, right? Okay, this is what I've been talking about. Please, please, please. Especially if you're somebody who's been struggling with this. As soon as you get that 0... No, don't check it. Here's what I want you to do a thing. As soon as you get that 0, Aries, do you remember what to do? Or what I want you to do? Me and Aries are talking about it. Where do I write it? Right in front of the 3, just do this as fast as you can. Because I don't want you to forget about that. As soon as you get a 0, hop up there and even throw parentheses around it if you want to, right? Because that's what we just found. We just found that thing, x minus 3. Thank you. Good memory. That's so important. That as soon as you get that check mark, write x minus up there so you don't forget it. And then you can go and populate your little synthetic division with your, I always make them green. I don't know why. You can go and populate it with what you need to, a plus sign, an x, a plus sign, an x squared, right? So we got x squared plus 2x plus 2. I'm going to save us some trouble. I think if we kept trying things, we wouldn't get them, huh? If we kept trying synthetic divisions, I don't think we'd get it. I'm just looking at that.
Oh no, I know.
But I do know a way to get that. What's a way to get that? The quadratic formula? Negative b plus or minus the square root. B squared minus 4ac all over. Indeed. And this is actually, I think throughout the year, this is where I made the most mistakes on when I was like plugging crap in because it's just so hard. The negative signs get confusing. So take your time. Go slow on the test. You have more than enough time, I hope. Negative 2 plus or minus the square root of not negative 2 squared, but 2 squared minus 4 times 1 times 2. If you're missing what we're doing, we're plugging this into the quadratic formula. Just so I didn't just jump ahead. All over 2 times 1. And that equals negative 2 plus or minus the square root of 4 minus 8 all over 2. Which equals negative 2 plus or minus the square root of negative 4 all over 2. As soon as you see that negative sign, what do? This is another like, as soon as you see it, you do it.
Why is there oh.
Circle it, bring it out, write an I for your next line. That's how I always think the I in my brain to get rid of it. I just circle it, rip it out of there. 2 plus or minus I square root 4. Oh, that's nice. I know the square root of 4, right? 2i. Can all those 2's reduce? If you don't like all those 2's reducing because of properties of fractions, break it apart into 2 fractions. Negative 2 over 2 plus or minus 2 over 2i. Turns into negative 1 plus or minus I, which is just I. I'm trying to be careful. I minus 1 and negative I minus 1, right? Oh, look at that. Wait, is that right? Did I mess up? Nope, nobody's getting this. Nobody's getting this one. I'm fixing it. I minus 1. No, wait, that was right.
Wait, why the I go to front?
I don't know. I just always put it in front. You don't have to. You can write it as -1 minus. They're the same thing. Addition is commutative. -1 plus I, -1 minus I. What? Yeah. I just flip them back and forth. You're allowed to do either. I always just put the I first because I don't know why. I got no reason. I just always see it that way. You can write it this way too. But so we got to ask ourselves what. So we got down to our simplest form. But what is this question actually asking us for? Real and complex zeros. So a 0 is a root, an x-intercept, and a solution, right? What was our first 0 that was the easy one?
3.
3.
-1 plus or minus.
-1 minus I, but you're more than welcome to write plus or minus in the set, and it's absolutely correct. How many roots are those? How many roots did we just write?
3.
We wrote 3 roots. How many roots should we have had if we looked at this problem at the beginning of the world? Or because of that right there, right?
Yeah.
Check. We can't find any more. That's it. That's our roots. Real and complex. Now, here, this is not on this problem, I know, but exploring, talking about the why of math. If I went to graph this thing, I'm not telling you we're going to graph. This is from the last unit. I don't know for sure if we do or not. What's the end behavior look like? It looks like a line going up and going down because of the 3. How many x-intercepts does it have? Only 1. Only 1, because those imaginary ones, I don't know how to graph an imaginary number. And it happens at 3, right? So I'm not even looking at the problem. Without even thinking about this problem, I know what better happened at that line, at that dot. It has to cross, right? Otherwise, those 3 things don't make sense. Well, let's see if it crosses based on our multiplicity. What's the multiplicity of 3? Just 1. There's only 1 root that's 3, right? There's 1 root that's 3. There's 1 root that's that, and there's 1 root that's that, and that's all 3 roots. What's up?
Why do we need to know the complex zeros if they never even crossed it? Like not even graph?
Because sometimes it asks you for them, like it just did. This was post-graphing. This unit, the unit that said complex zeros, was the unit immediately after learning to graph. Because then, hey, sometimes you can't graph. Sometimes you get down to here. And if you want to write it in fully factored form, it would be, what is it, P of x? Or yeah, it would be P of x equals x minus 3, right? Because the 3 root with the multiplicity of 1, because there was only 1 of them. X minus -1 plus I, ugly as it looks.
We wouldn't be able to graph.
What'd you?
We wouldn't be able to graph the complex.
No, you can't. This was not in a graphing unit. We never even graphed it once. We didn't even pretend to. X minus -1 minus I. That is the fully factored form. That's why sometimes it asks for it. Or if it asks you for the fully factored non-complex form, you would stop a step earlier. Sometimes they'll say fully factored form with complex numbers. And sometimes they'll say fully factored form without complex numbers. You would stop a step earlier at this x squared plus 2x plus 2 step that we got right there that I'm pointing to up there.
Well,
What if you just
how,
Those are the same thing.
how do you
Hang on, one at a time. Yes.
how do you know if that you're supposed to put a subtraction sign on those ones with the complex?
Because we always put a subtraction sign. That's what we were talking with Aries a second ago. When he said as soon as you get a root, throw a minus in front of it. As soon as you get a root, throw a minus in front of it. Because you want your root to turn into 0, right? So my root is that number. So I'm going to subtract that number from x to cancel it out.
Where'd you find a multiplicity of 3?
Just the number of times that I long divided and got an answer. If I were to go back and long divide again, if I were to long divide 3 into this one more time, no chance it works out. The multiplicity is the number of times that solution occurs. The number of times 3 occurs in the thing. If we were doing our quadratic formula and gotten a 3 down here, one of these is a 3, one of these is a 7. Now you've got a multiplicity of 2 for 3 because it happened twice. But because we kept working our way down, simplifying this problem into simpler forms, every time you get a root occurring is when you count it.
So when do we do the like 3 and 1 and then keep going?
For the quadratic formula, basically I just keep going until I get a squared term. And that's when I stop. Because then I can do the quadratic formula. That's what I always do. So if you start with 5, I'll go 5, 4, 3 with synthetic division, 2, and then I'll do quadratic formula. Unless I get the 4 and I see a really nice grouping thing where it's like x minus 1 and 2x minus 2, and I know I can pull one of those 2's out and turn it into x minus 1. Unless I see a really nice grouping thing, which I can show you an example. A really nice grouping thing looks like what the heck? I thought there was one on here. Oh, I guess there's not. I thought there was one on here. There's not. There's a really nice grouping one on the first review.
Oh yeah.
I think I could be wrong again. Maybe it's on the test.
No.
I remember seeing it recently. All right, let's keep going though. I don't want to waste all our time. Number 5. Okay, this will be on there, but I did say on the test, whenever we get to this, do not simplify. But for the purposes of today, we can simplify.
Is there some more space to work on the second one?
No, I'm not going to give you space. On the test, yes. But the reviews are just for you to go home and practice. I don't want to waste paper on that. Or waste, yeah. Yeah, I don't want to waste paper when I print them. Okay, given A equals P equals RT, invest $24.34, compound it continuously. I just made these numbers up. This could be the ugliest problem in the world. I literally just typed them in. So we've got our formula. And let's just try to remember what each of these stand for. Because this is what I told you. I told you that the book will do this. They'll give you the formula, but they won't say what they stand for. So your job is to look at that formula and remember what each thing stands for. So the A stands for, it starts with an A. Amount. P stands for, it starts with a P. Principal, which if you don't remember stands for what you start with, right? I don't know how to spell principal. No, you don't get stuff if that's wrong. The E stands for? Yeah, 2.71 whatever or something like that. It doesn't stand for anything. It's a number. The R stands for, and the T stands for time, which in our brains can think years, right? This time. Sometimes it might say minutes. I don't know. All right, so let's just plug in some stuff. So A better equal 2, 4, 3, 4. That is not how you spell principal. It's principal, right? That's a principle. That's a principle that you follow. Like, hey, this is a principle for life. This is actually I don't know.
That one's for like principal of the school.
Well, what's the other one? Well, then which one is principle? Like the amount of money you start with?
The one with the E.
Are you sure? I don't know. Somebody Google it. It doesn't matter. Capital. Think of it as capital now. It's not principal anymore. Capital. Same thing.
What's the E?
2.71. We don't know. We leave it as E. E is the special number that governs the universe. It tells us the rate at which things increase or decrease. E tells us how fast viruses spread. E is the number that is the average spreading number, 2.7165 something. I don't know. We don't know it. It's in your iPhone though. It's literally, you can just press the E button on your iPhone, so you don't have to know it. Yes, I was right. Well, I was originally wrong, but then I was right again.
We can't use calculators.
No. I'm going to say leave it. I'm going to say leave it, plug them in, and leave it on the test. So I'll show you where we'll be able to stop. And what does R stand for? Rate? 0.058. Right? Remember, we have to move that decimal twice. Not the. You don't move the percent sign twice. You move the decimal twice. I wish your teachers would have taught you that. I know a lot of them always said move the percent sign twice. No, move the decimal twice. And our time is. Oh, we have to do it twice. 3. And then you just have to do the whole problem a second time, but with 7. And that's where you would stop on the test. You would just leave that, right? You don't have a calculator, you'd stop right there. Cool. Here's a trick question to think about. I'm not going to do it, but I'm going to leave it for you to think about. What if they were like the ln of 5 years? Then you could do something cool. Right? That's it. I'm not going to do it for you, but that's like a trick question to think about. What if they were like the ln of 5 years? Yeah, and something cool happens, right? With E and ln. I don't know. You tell me. All right, what else? That's a helpful hint. We can look at that other review too. The other review is more like the test. If you're gonna go home or go home and study the other review, and we can whatever you want to do. The second one is, well, you got to tell me. I'm not picking problems for you. Number 20. Oh yes, we should definitely do this. This is great. I love the unit circle. Here's what I put on the review. On the second review, I know this is the worst one in the whole thing, but I put write the unit circle. And I said, I know this will be messy. I know this is messy. But what I said is, if you can do this, you'll be good with any unit circle question we ask. If you can write the unit circle, and how many points are there? 12 plus 4 is 16. There are 16 points, right? I said, if you can write the unit circle, and you can tell me every t value, which is called a terminal point or a reference point, whatever you want to call it, I don't care. If you can write the t value, and I gave you an example, like pi over 4 is a t value, right? And you can tell me for all 16 of those points, the point itself, and I gave you an example point. And then for each of those points, you can tell me the cosine, sine, and tangent, which is x, y, and x over y, then you're good. You'll be good for any unit circle question possible. So if you can from scratch do that, take this whole thing and write all 16 t's, and then take those t's and write all 16 points, and then take those points and write all 16 sines, cosines, tangents, you're set. So that's a thing to go home and practice. But this is just one little, 20 is just one specific example of doing that.
So you want us to do that on the test, or is it just...
No, I put it on the review because I said, if you can do that, if you can write that thing, then I don't know, one of the questions will be one of those, I don't know, that makes up 100 questions, right? It'll be one or two of those 100 questions that I could ask. The cosine of negative 3 pi over 2. See, I don't know it right now in my brain, but I know I could ask that question.
So what it means by the cosine, sine, and tangent values is that when we put in parentheses like cosine, this number,
Yep.
comma,
Yep.
but the only times that tangent is really, but how on earth would you label the tangent? Because it's usually sine or cosine.
I would write it off to the side. That's why I said I know it's going to get messy. The sine of pi over 2 equals 1. Sorry. The sine of 0 equals 0. I would write those out to the side for each point.
Because, well, the reason I'm trying to understand is because in the parentheses, it would only be the sine and the cosine.
Correct. And then off to the side, right? Tangent equals whatever. Off to the side. This is just because the question could ask you what's the tangent of that. So, okay. So it has a y coordinate of 4 over 5. What? Is that worded bad? What should it say? No, because we don't know that either. Hang on. What?
Oh, maybe, wait.
I know the problem is supposed to be asking about a 3, 4, 5 triangle, right?
Or maybe we have to use the equation of the x squared plus y squared plus 1.
Yeah, we're going to end up using that.
Oh, okay.
And I just did it in my brain to get 3. If you do x squared minus y squared, it'll be 3. 3 is the 4, 5. 3, 4, 5 is x squared plus y squared equals 1. But let me look real quick at where I got it from, just so I can make sure we don't just go down a rabbit hole that's not worth going down. Maybe there's one word that I forgot to type. HBU, pre-cal, textbook. Anybody know what unit that was? What like unit we did the unit circle in? Thank you. Thank you. That's so helpful. 5.6. Nope. 4.4, nope. It was 4.6? So here's the chapter 4 test. Do you see a problem that looks like that one? Tell me when you see that unit circle picture. That's what it'll be. That little red unit circle picture. Okay, what section did you say it actually was? That's that exponential function. It says 4.6 colon unit circle? Oh, I forgot to change it. That's my bad.
Well,
I'll fix it on next year's iteration.
is there a question? Is there a typo on the review?
No, I don't think so, but I'm looking to see. I just don't want to go down this long problem if there's a word I'm missing. Sorry for this. Just going to read the whole book real quick. There it is. Yep, there it is. The point P in the figure at the left has a y-coordinate of 4/5. Is that what it said? Oh, okay. Well, let's go for it then. I just want to make sure. The point P in the figure has a y-coordinate of 4/5. So let me go grab that figure, and we will just see what happens. Maybe life will be good to us, and it will work out nice and neat. So there's the figure right there. Cool.
On the review, you didn't put the picture.
Yes, I did.
Is there a board?
It's right there.
Oh, it's the same picture as the one above?
I think so.
Why isn't pi? In it?
Oh, if it's not, then
Oh wait.
No, because I got confused.
yeah, it is. Oh, it does say to the left. Is it not to the left on the review?
No.
It's kind of on the left. To the left of the previous problem. All right, sorry, I'm wasting our time. It is our break, though. Okay, so we know the y-coordinate is 4/5, right? So if I were to write that point, it has a blank for the x-coordinate and a y-coordinate of 4/5, right? And this is the unit circle. So what do we know about the unit circle? The first thing we wrote when we did our unit circle. The very first thing we wrote. No, before we even wrote that. Yeah, what did we write? Very beginning. X squared plus y squared equals 1, right? The very first thing we wrote was that.
Oh, so we just put the 4/5 into the one.
Into that formula, right? Let's find out. Let's find out what happens. I'm going to leave x squared alone. Ooh, I should not do that. X squared plus 4/5 squared equals 1. X squared plus, y'all good with 16/25? And everybody good with me mixing that 1 up and writing it as a better thing? Absolutely. And I probably get x squared equal 25 minus 16 probably gives me 9. Square root both sides. X equals plus or minus 3/5. Right? I'm going to be careful though. You're right. We're going to have to pick one, but let's go to the picture to pick it. Right? So now I got to decide, do I think x is a positive or a negative 3/5? Look at this picture. It looks to me like it's, if we're using the picture, and it does say use the picture, that looks like a negative, right? So I'm going to go ahead and X out the positive part. And why does it look negative? Okay, because it's the x value, right? We're solving for x. And if I look up at this, what happens to that x value? Does it look like it's going backwards or forwards? See how the x looks like it's going backwards to get to that point? Yeah.
Wouldn't it like wouldn't the easier way to look at it,
Oh yeah.
like on the graph, because the x values are negative at that point. So you just kind of just
That's what we said. Oh, you're saying at this point right here? Yeah, that point is something right here, right? The x better be negative and the y better be absolutely. And they gave us the y and it was positive. So we've got our x being negative 3/5, right? Now our job is to find the sine of t. Well, what does sine mean? Y, right? Sine, y, they sound the same. Swine. Think swine. Don't think that. I don't know. Sine of t equals 4/5. cosine of t equals negative 3 over 5. Tangent of t. Huh. What is tangent again? Sine over cosine, right? So that equals 4/5 over negative 3/5. And if you remember the shortcut that I said,
Oh, the 5's cancel.
the 5s do turn into 1s. They don't cancel, but yes. The 5s do cancel and you're left with negative 4 over 3. If you don't like that shortcut, what's the long way to do that? There's like a phrase for it. Thank you. You keep the top. You change division to multiplication. And you flip the bottom fraction. So you get 4/5 times negative 3 over 5. And you get, whoa. No. Ha. There was a chance. Nobody got it. And you get something like, is that what we got a second ago? 4 over negative 3. Sweet. That's just the long way. If you don't like, oh, see you later. Sorry. But we did get the same thing, right? Yep. Cool. That is the tangent. Okay, and then the secant. Ooh, that's hard. Flip cosine. It's not what you think it should be. Your brain thinks cosecant should be with cosine. It's not. Secant is cosine. So we just flip cosine. 5 over negative 3. Sure. Those are the same thing. And you know what else you could put? You could put negative 5 over 3. Right? The negative being next to the division sign, like negative 5 over 3. All the same thing. All right. That's pretty cool. I like that one. See, I thought it was going to be weird at the beginning, but it wasn't. It was possible. Now, do I know a lot of other stuff about that? Like, do I know that square root of 2 over 2 thing? No, that's a random point. That's like a random point that is on the unit circle and isn't one of our special 12. If you look that up, I don't know what 4 over 5 is. Is that like 0.8? Yeah, it is. 4 over 5 is definitely 0.8. Right? Yeah. Thank you. Did you say no, Alex? It's like, no. All right, what else we got? The very next one? Which one? I'm not doing all 4. Fine. Dang it. Okay. Good choice. Find the exact value of C. This is why I said you just have to know your dang unit circle. There's no shortcut here. This is just knowing your unit circle. So, here we go. I'm drawing the unit circle. Drawing a big circle around it. I have to go negative 5 pi over 3. I know everybody works on this in different ways. Here's the way that I would think this through. And you think it through whichever way works for you. I don't care. I don't mind. Here's the way my brain works through it. Is I know halfway around is pi over 2, right? Is 5 over 3 bigger than pi over 2? Yeah, right? Because 1.5 over 3 would be pi over 2. So my brain's like, okay, I know it's got to go past that. So I'm going to start working my way around.
Wait,
Yes, sir.
Isn't that supposed to be 3 pi over 2, but since it's negative?
I just wrote negative pi over 2 because it's the same thing, right? But it's also, that negative sign's ugly. I put negative pi over 2 or 3 pi over 2. You can think of it either way in your brain. Because you're always allowed to subtract 2 pi. Remember? Okay, but I got to keep going. So how far have I gone so far? I've gone all the way to pi over 2, but I got to get over to 5 pi over 3. Is that bigger than pi? Yeah, it is, right? Because that'd be 3 pi over 3. So this is the way my brain's like working through it. It's like, oh, that's even bigger than pi, right? Which is the same thing as negative pi. Okay, then is it bigger than?
I think of it like it goes halfway, so that's a 3.
Yeah.
So then you go
And then is it going to go another whole halfway? No, right?
2/3.
And then it's got to go up to here, right? And my brain thinks of that one, and I know it's weird, but I always think this is the 6th part, right? This is the 4 part. This is the 3 part. That's how my brain thinks of it.
So that would be like that would basically be
If we're looking at the denominators, this is always a 6 on the denominator. This is always a 4. This is always a 3.
square root of 3 over 2 over a half over negative half.
So then I draw my little triangle, right? Oh, does it? Did I mess up? Oh, dang it. That is 4 pi over 3. I messed up. There you go, dude. That's 4 pi over 3.
Wait.
And this is 5 pi.
Oh yeah.
This is 5 pi over 3. You're 100% right. If you want. I was going the normal style way and then screwing myself up that way. So that is negative 5 pi over 3. And if you don't like that, you know a way you could think about it? Which is what I would then go and do if I were working this on a test. Did you add 2 pi? Yeah, you can add 2 pi, right? You can always add or subtract 2 pi every time. It's your identity. So if you add 2 pi to that, what do you get? Hang on, I'm gonna do it slowly. Equals negative 5 pi over 3 plus 6 pi over 3 equals pi over 3. And that one you have memorized on your unit circle, which is the point that we should have landed at in the first place, going the regular way. That might be an easier way to do it. Yes.
Can I convert it to the unit to like quadrant?
If you know how. If you know how. Times 180 over pi? Absolutely. We just didn't spend a day on degree conversions. Okay, so then our question is, let's draw that triangle and ask ourselves about the long side and the short side. I know right away that the point should be the short x, long x, right? Both positive. So probably 1/2 square root 3 over 2. Everybody cool with that? Unit circle. Get it memorized. If I had it memorized, I wouldn't have made that mistake. So this red arrow going around is negative 5 pi over 3. And this blue arrow going around is pi over 3, which is the same thing as 7 pi over 3, right? Which is just another way to think about it. Okay. What else we got? $14. Ooh, laws of logs. That's good. We did that very quickly. So many laws, right? Here we go. What are some of the laws? Division turns into multiplication turns into exponentiation turns into multiplication out front, right? Like that. Those are the only 3 laws? There's some laws about like log b of b equals 1 and the log anything of 1 equals 0. Log AB equals log of B over log of A. Change of base formula equals ln of B over ln of A. We did that to see that it was the same. Oh, good call. A to the log A of X equals X. So this might be one of the things one of the free response parts on the test is literally just like, hey, there's a bunch of laws for logs and exponents, and there was one other thing that had laws. E and natural log. Yeah, that was it. It was E and natural log, even though those are kind of the same. There's a bunch of laws for the natural log, E, exponents, and logs. Write as many as you can. That might be one part. So E and log. Write as many as you can. The other thing would be, I'm trying to remember, they were like, it was more free responsey. Like, I'm not giving you a number of things to get. I think I'll give you parentheses like I got 20 or I got 18 or something. Kind of like we did for that extra credit. And so it's not like, oh, you'll get a grade based on the perfect right thing. It's how much can you get in here, not just I don't know, see a problem and recognize it, but how much can you really talk about? So it could be a really quick section or a really long section, depending on. And then I might even say make up a problem, like underneath each law for full credit, like for a 85 or a 70 or something, I don't know, just say the law. For full credit, make up a problem and do it. And if you know the law really well, guess what kind of problem you can make up? A really easy one, right? If you know the law really well, like if you know the law that ln of e to the 2 is just 2, then that's the problem, right? And you're done. But if you don't know the law really well, then it's hard to make up an easy problem. Or you could even do ln of e to the 2 in two different ways, right? You could do it this way, or you could do it this way, and it's the same thing, right? They're both. I mean, it is true either way. Okay, so, or actually, what I'm saying is that applies to two laws. That applies to the ln of e law, but it also applies to the exponentiation turns into multiplication and our logarithmic laws. Okay, sorry. All that to say, which one do we want to do? C, huh? Yeah, C's ugly. Ooh, we should write that a certain way. I should write the whole thing and change the square root to something prettier. There's one other way you can write a square root. 1/2. So my first law I'm going to apply is that one, right? So this one has like every law in it. This is kind of cool. All right, second law we can apply. Subtraction law? I'm okay with that. But here's a thought. That 1/2 is multiplied by this whole thing, right? So it's going to stay multiplied by whatever we end up getting. We're just going to keep a 1/2 out there, right? I'm not going to go and distribute it every single time yet. I don't want to mess up with it and do it twice and get a 1/4. I want to just leave it on the outside, solve the inside, and then keep it at 1/2 on the outside. And then you want to distribute later, be my guest. But why would you? All right. So this better equal 1/2 of log of x plus 2 minus, ooh, we're going to have to be careful, log of x squared plus 4. Yeah? Okay. There's one more. Multiplication turns into addition. This red multiplication better turn into addition. So we will end up with 1/2 log of x plus 2 minus, ooh, I got to be careful with that minus sign. It'd be so easy to just subtract the first term of our new addition and not the whole thing. The whole thing, right? Log of x4 plus log of x squared plus 4. It'd be so easy to just subtract that first one and not the rest of them. I see one more. I actually see one more. I didn't see it before. I know I said one more a second ago. I didn't see it at first. What'd you say, the 4? Where can that 4 go? To the front? So we get 1/2. Big old parentheses. I'm going to switch to parentheses instead of brackets. They're the same thing. Log of x plus 2. I'm going to go ahead and distribute. You okay with this? Minus 4 log x minus log x squared plus 4. That's a good question. What'd you say? Other x squared? Can we do the same thing with the other x squared? You would have to separate them out and get it, the whole term squared, right? Can you separate them out? How do you separate them out? You can't. Wait, x.
Why is there a minus?
2 times 2 is 4.
Oh.
What?
I don't have enough
What?
room on.
No, we can't factor that. That's not a perfect square. You could do x squared plus 2, but then you'd have 4x in the middle. No, that answer is 2i. That's a 2i, right? Move the 4 over, you get negative 4. Square root it. You see what I'm saying? You just leave it. You can't do it, right? Yeah. Oh, yeah, 100%. If you want to see that as, watch this. I should have been doing this the whole time. Boop, 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 boop. Like that, you mean?
Yeah.
That's A-okay.
Don't you do the same thing to the x squared that you did x to the 4?
That's what he was saying. Because it's not all of that squared. So the rule is the log of, I don't know, call it a random thing, A squared, right? And then you move that 2 to the front.
Oh, outside.
Yeah. Whereas and the reason why this one was inside the parentheses right there, the only reason why is because technically it doesn't matter. Technically you could put a billion parentheses there and it doesn't change anything, right? I could keep going parentheses around that x and it won't change anything. But if I go over here and start throwing parentheses around that x, well, no, that doesn't change the problem. But if this is not this, right? Those are two different problems. And they're not, the whole term is not squared, right? I can't apply this because the whole term is not squared, whether the whole term is in parentheses or not. The whole term better be squared. Like we don't have a rule for log a plus 2 or a squared. But by golly, if this was a plus 2 squared, we could take it out there. Or even if this was a plus 2 squared and it looked differently, it looked like, well, no, we'd have to do that. But it looked like that, and you have double parentheses, and it's still inside of these big parentheses. Basically, what I'm saying is, and a lot of times they show you that in the book, the parentheses around the log don't matter, right? A lot of times you see the log without parentheses. You know, in the book you see it all the time, where it's like log of x, and it just literally writes log of x. They're showing you these parentheses don't actually matter at all. The parentheses that do matter, though, are telling you where it ends if you've got a long term. So, yeah.
If you go
Yeah, absolutely.
so couldn't you just use like the in red, like zoom in on the part in red?
The middle?
Yes.
Yeah.
So couldn't you have just used the other law to just simplify that because it is plus? Couldn't you have just multiplied those two? You could have like eliminated the log and then multiplied x to the 4.
Multiply which two?
Multiply the 2 that's inside of the parentheses because it's like could you have just used?
Are you talking about this one?
No.
This one?
Yes, like couldn't you have combined like both of those? Because you could have used the other like law to combine them.
We uncombined it. That was the whole point. Right there. Oh. Could we have? I see what you're saying, and I'll take you a step further. Could we have distributed this x to the 4th?
Yeah, that's what I was.
Yes, but that makes it x to the 6th plus x to the 4th, and then we can't pull anything out. I mean, you could pull out your x to the 4th, which is just pulling out a 4, which is what we ended up doing only for one of those two terms, not both of them. The problem is that plus sign. The big problem with the whole thing is that plus sign. We don't have a log of pluses. We don't have a thing simpler than plussing or adding to change our log. Like we only have logs with multiplications turning into pluses. We don't have logs of pluses turning into something else. Excuse me. Yeah, absolutely.
Or zoom in on so I can finish writing the problem.
The whole problem? That?
I have a
Sorry.
question.
Yes, sir.
Is
Sorry.
putting the 1/2 in front of it like you did in the answer.
Uh-huh.
Is that still kind of correct, or do you have to put the whole thing over?
No, it's right. Your English just asking, hey, I wrote it like this. Is this the same thing? And I was saying, yes, absolutely the same thing. It would be corrected, multiply by 1/2. Heck, it'd also be correct to distribute the 2 and have every individual term divided by 2. Don't do it. Extra steps for you to maybe mess up, but you could, and it's true. And it's correct. This is good. This is a good review.
We could go over like the types of like the financial question. There's like continuous. There's
Just the one we did is good.
no,
For Friday, the one we did is good. The different types are continuous is E. Here, I'll do that in that section. Where was that section? Here we go. Boop, boop. The types. Continuous was your amount is equal to PERT, right? And then there was compounding, which was your amount is equal to P times 1. Whoops. 1 plus. Y'all remember it? R over N. The 1 was the 1. R over N, NT or RT? I think it was NT. Yes, that's right. Because the 1 R over N will get you your decimal. R over N will be a decimal, right? Because N's usually a positive number and R is usually a decimal. And that decimal is that decimal amount. This number right here, the 1.025 or whatever, is telling you that you're growing at a 0.2025%. Like if it were just 1 right there, you just get your principal every year. No, just 1. Just 1.
Wait, it's either this one or this one.
Yeah.
Oh.
You know, the thing I mean, money packs.
No, it's
If you get me wrong today, you can have the second one. That's the rule.
oh, okay.
That's why Alex and Caden. Alex never got his, but yeah. There was one other formula. A equals P 1 plus R, and that was it. That's simple, right? Simple interest. This is not compounding. This is what we wish banks did. This is what banks actually do. And this is viruses and naturally occurring exponentiation.
annually is like
Oh, annually is 1.
semi-annually is
Semi-annually is 2.
quarter is 4.
Quarterly is 4. Monthly is 12. Daily is 365.
Yeah.
Semi-annually, technically, sometimes they'll say biannually.
Are you gonna provide those
Ye-
equations?
I will provide the equation, but not what each thing stands for. Yes, that's the way the book has been doing it. Is they give you the equation and the problem, but they don't tell you like, oh, P stands for principal, R stands for rate.
There's one more equation.
Do you remember it?
Something like 1 plus R over N to N minus 1.
I don't remember it. I'm not gonna go back and look. Scrolling through the book. It's definitely not common. I should remember it, but all right. What else we got? We got plenty of time. We got 30. Oh, we still have a lot of time. What'd you say on the other one? What? Graph the unit circle? Oh, graph a wave. Yeah, we should do that. That might be. Yeah.
It's the last one. It's just that you wrote the unit circle. It's on the other
Where is it?
on the other test review. But you wrote the unit circle over. It's right there.
Oh, it's just. I see. I did not see it. It just looks so simple. Okay. Yeah. That unit circle, still a really good thing. I'm not lying to you. That's a really important thing you should know. Graph that. Notice we don't have a horizontal shift. I'm a man of my word. Perhaps on the final, but not yet. There's no horizontal shift. Though perhaps on the free response, as part of the thing to get full credit, there might be a horizontal shift that you could talk about. But we'll see. I'll talk about that at the end of the class. Okay? If we do have a graph, I will either give you a perfect scale or I'll let you pick your own scale. So you don't have to write in your scale till later. But we should be able to say a few things about this right off the bat. right off the bat, there's one thing I see that I'm like, I know the biggest number this thing can be is 5. That's called something. It's called the amplitude. And as soon as you get your amplitude, go to your graph. Either if it's labeled for you, plot it. If it's not labeled for you, write it in yourself. And you know what I'm going to write at 5 and negative 5?
Did you say you was gonna already have a place on it?
I'm either going to give you really nice ones that work with the problem or leave it blank. It'll be one of those two things. Maybe one of each. I don't know. But if it's blank, you pick your points like we just did. And if it'll still have the grid, it just won't have points, so you can make it perfect. Like if it intercepts every 4 pi, you can just go 4 pi is 1 box and then make it super easy. So I'm going to draw a dashed line right there, right? And what does that dashed line tell me? What is that dashed line telling me about this wave? Max and mins, kind of max and mini. It doesn't cross it. It's where it turns around. Peaks and valleys, peaks and troughs. If you remember that from physics class. Okay. Anything else we noticed about this?
Is it a horizontal compression?
The inside, right? Multiplication inside means horizontal compression of 4 times. Holy moly, that's a squished up. Oh, it also tells you a period, right? T equals 2 pi over 4 equals pi over 2.
How do you know it's 2 pi over 4?
Good question. The formula for period is 2 pi over. Did they use B or K? What did they? K. K being your constant of your spring constant. That's fun. If you anybody taking a physics class, K is also the spring constant. It's the springiness of a spring. Which, if you think about this in terms of waves and like that makes sense, right? The springiness of a spring is determined by whether it looks like that or that, right? If the spring looks like that, probably a high K value, high K constant. The spring looks like this, probably not very springy. Yes, sir.
But how can we tell that the K is the 4?
It's that inside number. That is K. It's just what they call it. Okay. So, and then our last thing is we need to know what the cosine wave looks like. What does the cosine wave look like? Well, maybe we should just plot 0 to get a head start. What's the cosine of 0? From our unit circle that you already knew from the last section.
It's 1.
It is 1. So if we plug 0 into that, we should get 5. So if I go to the point which is 0, my first point is up here. And that can help me remember what cosine looks like. And how long does it take me to make one complete revolution? Pi over 2. So if I'm allowed to make my own points, here's pi over 2. I'm going to repeat. And what does cosine have to do in between those two things? Go all the way down and then all the way back up, right? And what's probably it's going to hit the minimum at? No. Pi over 4, right? Cut it in half. Let's find out. And if I had to guess, where are those x-intercepts probs?
Don't we have to fill a table or something to find this?
You don't have to. Just guess. If this is pi over 4 in the middle, guess what that x-intercept better be? Oh, close. Good thinking, but I don't think 6 is half of 4.
8.
Pi over 8, bless you. And 3 pi over 8? No. Yes. I don't know. Go check and see. 5 times the cosine of 4 times pi over 8 is what? 5 times the cosine of pi over 2? What's the cosine of pi over 2 in your unit circle?
It's
0. Because that's the vertical thing, right?
Yes.
So it checks out. That's the 0. That's an x-intercept. You'll probably only need to graph 1 revolution. So if you want to be safe and you have extra time, feel free to keep going. That's cool. I love that.
Can you just draw it, or would you need like the points highlighted?
It'll probably just say graph one revolution or one what's the word? Period.
I mean, like from looking at it, can you just draw it and like not write what it
Well, if there's grid lines, you better hit those grid lines. But if you pick it such that the grid lines, like, I don't know, if you pick it such that you're going in between grid lines for your thing, don't do that, first off. Like, let's say you know it rotates every pi over 2, so you just put it in the first little thing. Go, well, pi over 2. I don't know. That's ugly, but I guess it's true.
Are we gonna have suggested homework for these things sometimes?
Nope, just work the review.
So we can.
Your best suggested homework is literally this review, too.
Yeah, but since.
I can literally write a little note that says, hey, link to this on your suggested homework, but this is the best thing you could possibly do over the next 2 days. This second version just for extra help.
The reason why I was wondering is because I just did that question, but how am I supposed to build a practice, continue to practice this concept with another one? Like, because if there's only one question with this concept that I've already did, how am I supposed to get more practice?
Do you have the book?
I do have the book.
You can literally go grab any of them. Or if you want to, you could Google graphing cosine and sine waves. CUDA. Actually, here, watch this. I can do that real fast. Boop. 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 Boom. 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 Watch this. Copy and paste. Boom. Watch this. It's there now. What week is this? This is 9. This is not 8. This is 9, huh? Wait, or is this 8?
This is 9.
That's crazy, y'all.
This is week 8.
I don't know.
8 was last.
I think it's 9. Because I posted the review early.
Oh.
Oh, I did.
Oh, no. Where did it go? Boop. Boop. What's it called? Graphing, sine, and cosine. Link to it.
Because that's probably one of the concepts I might need the most practice because it's kind of, I was kind of confused about when we were doing it on one day.
It's there. Don't say I never did nothing for you. All right, what else we got? It's under suggested homework now. If I think of other topics like that, or you do, email me, and I'll post a link to it. Be happy to do that.
Can you do 16?
Can I do? I can, yes. Oh, that's awesome. These are good problems.
The exams on Friday.
Indeedy duty. That's why we're doing this. And like I said, feel free to come back on 12 o'clock to 2 o'clock. I'll be here doing this exact same thing. Maybe we do some of the same problems. Hopefully we do some different ones. I'll post all 4 hours of me talking on the website thing, YouTube. It might take a minute to upload, though, so don't get mad at me if it doesn't come right away. But I know we only have 2 days, so I'll do it as fast as I can. I promise you won't be rounding to decimals on the test, but for today, quite possible. Oh, we don't need to. No, none of these need decimals. First one's so easy. Holy moly. Look at this first thing.
Where's this?
I don't know. This looks like problem 16. Sorry, I know that's in front of everything. This is problem 16. How do I get rid of a base 3? Log it, right? Now, some people, I think Miguel, I don't remember who said earlier, when we learned it for the first time, he's like, can't I just see that and know? Yeah, you can see that and know. When you look at the tops, you can see that and know. Those exponents better be the same, right? Like 3, you can just see that and know. If the 3's are the same, the exponents better be the same, so you set them equal to each other. But if you want to be mathematically safe, you log 3 it, right? Right? And what you do to one side?
You do to the other.
Oh, I can't grab. Sorry about this. You log 3 it. Actually, technically, if I'm being safe, it looks like that, right? And then what are you allowed to do with those exponents? Bring them to the front, right? So technically, I'm just being safe with math, y'all. 4x times log 3 of 3 equals log 3 of 3. Whoops. Equals 100 times log 3 of 3. What's log 3 of 3? It's 1. So 4x equals 100. So what does x equal? Sure thing.
What I'm concerned about is C and D look difficult.
C and D look difficult? Let's check it out. Let's try C. Ooh, D does look difficult. Let's do both of them. Those look fun. Here, let's do C. C. 5 x over 10 plus 1 equals 7. I think there's an obvious first step. I could be wrong, but I think there's something you should do. You should definitely get that one, right? Why have two numbers when you could have one? Okay. Everybody's okay with that first step? I guess I could have been nice. Okay. How do you get rid of that 5? Log 5 it, right? That's like the lesson of the day. And what you do to one side. Ooh, we're going to need our little rule. So now we're left with x over 10 equals. Well, I almost got x by itself, actually, don't we? Now, how do you get x by itself? Times 10, right? Times 10. I'll put it in front because we always see it that way. 10 log 5 of 6. Now, I posit to you there's a better way to write this for you and your calculator knowledge. I posit that you can't type that in your calculator. But you know what you can't type in your calculator?
Well, how are you supposed to do it without one?
No. That's kind of fun. We could do that, couldn't we? I missed that. Yeah. Interesting. Okay, I'm gonna do two branches. I'm gonna do two different things, and we're gonna see which one's cooler. Edwin just said we can do log 5, 6 to the 10, right? You think I'm doing 6 to the 10? Heck no, I'm not doing 6 to the 10. That'd be crazy. Here's the branch that I was thinking was 10 times. You know what I can turn log 5, 6 into? Log of 6 over log of 5. And what's the base when I don't write a base? Try standing up. It's been almost an hour. Get some fresh air. Not now. But what? This is what I would say because you can type this in your calculator and you would leave it like that on the test. You can't do it on the test. You can do it right now, but you can't do it on the test. What's up? That's fine. That's be the perfect answer. And I actually do that too. But this is more what the book would say. No. No.
How about the first option?
The first option's cool, but then I would even go a step further and say this is the same thing as log 6 to the 10 over log 5. Because I can type that in my calculator. Oh, and that's cool. Because that makes me be able to see on the bottom, I can move that 6 to the top of either of them, right? Well, no, I can't move it to the top of the bottom because it's technically 10 over 1. So I can move it to the top of the 6. Or I can make it the 10th root of 5, but I'm not going to do that. All right. Any last question before we wrap up and check roll B? D on this one? Dang it, it's the same thing. It's not the same thing. Here, I'm going to do it on the same page. That way I don't waste a page. That's C. What was this one? B or A? This was A. Here's D. 10 to the x plus 3. Oh, this is easier than you think it is. This is much easier than you think it is. It's scary because it doesn't look easy at first. Because you just what? You do anything. You don't have to. You can be generic and non-specific, right? Just write log, right? And actually log works nice for us because 10 cancels, right? So that one's actually going to be nicer than the other side. Log of 6 to the 2x. And now what can I do with both them exponents? Bring them out front, right? So now we got x plus 3 times log of 10 equals 2x times the log of 6. Any of those cancel? Log 10 is just 1, right? I probably need to bring that 2x over.
How are you getting?
How am I getting what? I'm listening. The 10?
Isn't that cancel?
What, log 10?
Yeah, log 10 cancel.
Yeah, I did. I turned it into a 1. And then didn't write it on the next line. X plus 3 equals 2x log 6.
And when the left equals log 6 to 2x, then we move those 3 to the other side.
Yeah, I need to get all the x's on the same side. That's like step 2. If you think about this is so long ago. Think about that DCMAM, distribute. There's nothing to distribute. Combine like terms, that's the x's. Move all the x's to the left side, that's that third in. Add or subtract all the regular numbers to the right side. Divide by your coefficient. So even though they're ugly numbers, the steps didn't change. Subtracting this from both sides, right? And you should get x minus 2x log 6. And can I go ahead and move that 3 over without anybody freaking out? Equals negative 3. What can you pull out of the first term? Can pull x out, right? X parentheses 1 minus 2x. Nope. 2 log 6 equals negative 3. So x equal negative 3 divided by 1 minus 2 log 6. It's not pretty. I'll zoom out. I know I got messy with that other problem. You know, it's not pretty. My college algebra students were hating the same methodology that is. Whenever we had to, this past test, move. What do we have to do? I don't remember if it was radicals on the bottom or something. But for some reason, they had to move stuff over, distribute it, and then move it back like we just did to pull out a common term. Oh, it was inverse functions. Doing the inverse functions of a... We did inverse function in this class, remember?
Yes.
Remember the 4 steps of inverse functions? There's such a similar concept of what we just did on inverse functions with rationals, where if you have like y equals... Don't write this. X plus 1 over x minus 2. You switch... Remember, inverses mean you switch, right? Y plus 1 over y minus 2. And then you have to move the y minus 2 over. And then you have to pull out common terms, distribute xy minus 2x equals y plus 2. And you have to get all the y's on the same side and pull out the y together. It's that same concept of I need to get all of the things that I want to get on the same side of the equal sign. Okay, let me check roll. Let me pause this recording. That's going to be the longest recording ever.